All right, we are recording and presenting. Cool. Well, welcome everyone to this month's community meeting. It's been 2 months since the last one because of the US holiday, so we'll cover a little bit more ground than a usual community meeting. So let's dive right in. Thanks everyone for joining. We have a packed agenda. Workloads and ops are standard checkups. What's on the horizon, our health checkup, and then some updates from various parts of the project. So let's jump right in. Of course, we have to start with a reminder. All of this is in our README, so feel free to check there too. We have the first Mondays of the month at 9 a.m. Pacific is the community meeting, and then the other Mondays is the developer hour. So the difference between those is that this one, the first Monday of the month, it's recorded and has an agenda, and we publish all that. The developer hour is a bit more freeform. Sometimes we take meeting notes, but we generally don't record. And sometimes we schedule specific topics, but not every time. And then, yeah, just pumping again, Ramiro's office hours from 8:30 to 9:30 Pacific. That can help if you're working on implementations. And then, yeah, we have our Discord channel and our discourse forum. So feel free to join all of those. And again, this is on the README if you need to check it. All right, so let's first dive into our usual statistics. So we have grown a lot. Our commit rate is up 70% in the last 2 months, and the set of contributors is bigger and more well-rounded than ever, I would say. So yeah, big thank you to everybody I have listed here: Nod Labs, Cerebrus, Google, Alibaba, Cruise, ByteDance, Microsoft, ARM, and a few others in the other category that I had to put together. Thank you so much for all your contributions, and I love seeing the community be vibrant and self-sustaining like this. Okay, let's jump right into the updates. Anush, do you want to kick us off on the workloads?
Yeah, so the highlights we have so far, we have Bloom fully lowered through Torch-MLIR. That's the openly available Hugging Face large language model. And we do have some enhancements that Sean is working on with kind of moving weights out and making it easy to compile, etc. That's in a WIP branch. We do have Stable Diffusion also working, vDiffusion. Obviously, this was just a simple example that we had where I think the prompt was Taj Mahal sunflowers 4K or something like that, and we got this. All of it lowered through Torch-MLIR, executed via Erie on CPUs, GPUs, and some custom accelerators, all validated and all generate the same image. So just goes to prove the robustness of the lowering for Torch-MLIR. It's no longer like, hey, ResNet 18, ResNet 50. These are like large, complex LLMs or image to image or text to image models like Stable Diffusion and vDiffusion. We have added vision transformers. We do have OPT also working. We started OPT before Bloom, but Bloom is fully open source or fully available for anyone to use in commercial settings. So we switched our focus to Bloom, but we wanted to finish OPT too. So OPT is also available for those who want to use OPT. After 66 billion, I think you have to have some special contract to get the weight, but the lowering and all that works. We had some customer interest in TOSA. So in the past few weeks, our team has helped shore up BERT to TOSA and also GPT to TOSA. We started some work, and there's quite a bit of, I think like 4 or 5 ops that are still remaining. We're working with Suraj and Eric to get that also to work. But I think with this, we're getting to a point where we're very confident in any model that comes our way. There's probably work to do, but the work we do kind of contributes towards lifting all boats, and it's going to be a lot more mature, and we have more things in the horizon that we'll talk about. But I'm just excited to see that we're about a year in from when we started Torch-MLIR, or we renamed to Torch-MLIR, and to see where we are. Just state-of-art models can go through Torch-MLIR is all we need to talk about for like maturity of the project. And thank you all for the contributions to get it here.
Yeah, and thank you, Anush, for all the hard work that your team and others have done on these models. I've been surprised. Like, I remember Bloom, like you started talking about it not that long ago, and then here it is working, and Stable Diffusion, same. I really want to figure out how to run this locally. I'll have to clone some of your repos, and I think our next community meeting slideshow will have a lot more images and artwork in it. So
it's good. Once you try it gets addictive. So it's pretty good, and I can see why the hype around it exists. But it also kind of proves the point with Torch-MLIR. Like, we can actually target as fast as we brought up these models. We were able to target the various hardware behind, right, and optimize for them also, which is kind of the key value prop of what we bring with Torch-MLIR itself. So it's very exciting for that.
All right, let's move on to the next slide. Ramiro, thanks for putting together this slide. It's too many to actually list off one by one, but I mean, as you can tell, supporting those models has required a lot of new functionality. And thanks to everybody for putting together all of this work to make those end user applications function. Yeah. So what's next for Torch-MLIR? So what next Monday at the developer hour, we have a discussion on sparsity. So please join that if you're interested in sparsity, and that can mean many things to many people. So the more people we have, the better. There's been a desire for this custom op or native op authoring. There's been a long time request, and I've been working with Ramiro to put together an RFC to kick off like a 1 to 2 quarter effort to enable this. So I'm hoping that this will, greatly ease the use of Torch-MLIR in a lot of contexts and unlocks some new functionality. This can tie in also potentially with sparse and other things. So I'm really excited to get that working. There's a push to support. Up until now, we've been building against the PyTorch CPU packages, but supporting the PyTorch CUDA and ROCm packages is going to give us access to all the GPU D types and everything, so we can import the GPU models as is without converting them to CPU. Bit of a technicality there, but it really is going to enable us to capture the models exactly as is, and that ties in a lot with our packaging and stuff. So thanks, Anush and folks, for pushing on that. That is not easy work. And finally is the Torch Dynamo support. So we had a meeting with a bunch of the PyTorch core devs, and we have meeting notes available for that. And the bottom line is we are aligned on direction, and most of what we need is in progress with them. So we will be aligning with them and making sure that we are having our interests represented there. So they also mentioned that Torch Dynamo will probably merge at the end of this year, and so we probably will bring in some form of Torch Dynamo official support, in Q1 of next year. So that's great. And then part of our long-term magic plan to delete half of Torch-MLIR and have it magically be done by PyTorch. There seems to be alignment there, and that's going to make it's going to make Torch-MLIR much leaner and meaner. It's going to reduce a lot of duplication along the projects, and that's a 1 to 2 year effort, but everything seems aligned there as well. So please check out the meeting notes and slides there. It's pretty exciting that things are working out like that. Are there any questions on this slide on the future directions?
I have one quick one. Yeah, just on the custom op, when you and Ramiro have the RFC, there has been an ask for the custom op landing in the backend contract, being like there are custom ops represented in external projects like Onyx MLIR that we may want to make sure that there's some like, okay, this is how you tap into at the backend contract level. I don't know if it makes sense, but there's just something to keep in mind when you're designing.
Okay, great, thanks. Yeah, if you're targeting the backend contract, actually things are actually easier. So hopefully that should be a no-op in terms of support. Cool. Just I feel obligated to ask some of these questions just to make sure we have a. Oh, Suraj.
Apologize in advance for the sound quality, but I'm on vacation today, and my question is, in the previous slide, is there anything about, in addition to custom ops, something about quantized ops and Torch-MLIR going on?
Yeah. So for quantized ops, actually, we have a community meeting due, or a developer hour that we need to do on that. I've still been trying to find the right set of people and interest to make that happen. And it does cross into upstream PyTorch's quantization strategy as well. So I'm very interested in that, and maybe we can make a GitHub issue and get some eyes on that, and just drum up some interest in that.
Great idea. The issue would be a great start, I think.
Yeah, I think the most difficult part here is the connecting what is available at the PyTorch front end level, which today is very limited, with what folks on the backend level want to see. And so we have to kind of like, both of those are still sort of up in the air, and we need to basically find a way to define those better so we know what we need to implement.
Yeah, and I think it also leads into some of the custom numerics and things that may not necessarily be supported in PyTorch right now, right? Like blocked floating point or something else that like what I think we had some Q PyTorch based entry points, and then there are some other ones like int4 support and others that that PyTorch, it's not on the roadmap yet, so we have to do something custom anyway. So I think that it'll overlap with the custom op in some way, and for now I think we just have to do like case by case, unblock ourselves and use that as like building blocks for the native op authoring infrastructure.
Yeah, so if I can summarize that, I think it's in cases where PyTorch doesn't have the right kind of front-end support, we will need to use custom ops to enable a special programming model for users, basically.
That's pretty much the intersection between custom ops and floating points I had in mind.
Sorry, what was that?
I mean, that's pretty much the intersection between quantized types and custom ops that I had in mind. So
okay,
let's start with an issue. Okay,
cool. Yeah, let's figure out what to do there. All right. Okay, I have to just ask these questions. Is anybody's workflow being affected by CI slowness, review times, difficulty debugging the project, or inability to ask questions? Going once? Going twice? Okay, great. Oh,
I just want to add a comment. No, so just wanted to thank Sambhav and Akshay for contributing to the CI work. The first bunch Sambhav did, and now Akshay has done quite a bit of work on getting it up to a good place.
Yeah, and we actually have 2 slides later about that, so we're going to dive in. A lot of awesome work has happened there. Well, great. It's awesome to hear that that the project is going smoothly for everybody on all these basic project health issues. If you're watching the recording or have any issue, feel free to just drop it on a GitHub issue, and we can figure out what to do about that. Okay, just one other topic that's been on my mind has been that Torch-MLIR is really growing up a lot. So as you guys saw, the amount of the commit rate has gone up significantly recently, and we actually now have like 3 backends that are being worked on like pretty intensively. And so one issue that I've seen happening a few times is when there's an issue in one backend, somehow it propagates to the other backends. So this can mean turning off a test for one of the other backends, or somehow not being able to enable a test for the backend that needs it. We should really avoid that at all costs. And if we do have to do that, let's definitely file GitHub issues, just so that we absolutely know that we can address this, because yeah, it's really, really, really important for the project that the backends can be developed independently. So in the last 2 months, we've added some features that enable that, to enable the tests to be able to control certain things about the testing framework, and to control decompositions. So that that should help things. But if we see anything else happening, please let's raise that to a project level awareness, because it's really important for the health of the project. We have sort of an informal RFC process, where we kind of label GitHub issues RFC. We've used those from everything from the adding MHLO support to suggestions about how to implement ops. I think that's working well. I'm wondering if anybody else in the community has any suggestions or feedback about this process, because we can definitely adjust it as we grow up. Does anybody have any feedback on the RFC process? Quinn?
I've just been using it a lot, and I think each time I've used it, it's worked pretty well for me. So I just wanted to say that.
Okay, great. Thanks, Quinn. Yeah, great. So that's good to hear, and let's keep doing a great job. I do also want to remind everybody about the LLVM coding standards. This covers coding style and also incremental development and some other things. As we're growing up, and the project is becoming more mature, it's becoming pretty important that we start to follow these. So these are pretty well tested coding standards as far as long-term health of the project. So I just wanted to remind everybody, feel free to please read this document and reference it in code reviews and other things. We definitely want to we have been keeping the project generally to the LLVM standards, but now that we're growing, it only gets more difficult to maintain that quality. So we should be very, very aware of that, and making sure to hold to the standards. I also, in the architecture document, which I'll talk about in a second, there's also a section about do's and don'ts for unit versus end-to-end testing. So because of how Torch-MLIR works, we need to do a lot of end-to-end testing. And so in the architecture document, there's some recommendations for how to do that, and when or when not to use more classic unit tests versus end-to-end testing. So please do read that, and please reference that in code reviews. I've found that pretty handy recently. All right, let's go to the next slide. Yeah, so speaking of that architecture document, this is the link to that architecture document. We need to do like a whole talk on this, probably at an MLIR ODM. But this document basically gives the high-level description of how the project is structured, why it's structured that way, and this should help understanding the roles of the different pieces of the project. So yeah, I'll need to find a time to give an ODM about that, but for now it's in written form there and has lots of great information. So please do read that. All right, yeah, just one piece of that, which Anush was mentioning, and is kind of a weird term, is the backend contract. So the good thing about this is we've formalized that now. So there's actually a function in the project which checks if a module satisfies this contract. And so that's described in detail in the architecture document. And it's proven to be really useful. For example, the Onyx MLIR project wants to target our backend contract as well. And so this is actually taken straight from the docs. So I'm not going to read this all out, but the backend contract basically is a subset of the Torch dialect, which is normalized to have a lot of really great properties for backends. Okay, let's go on. Siraj or Eric, do you want to give the TOSA updates?
That's a good question. Eric, would you like to cover this or me?
Go ahead for it. Okay.
All right. So we had a recent conversation with Anish about support for boot and GPT-2 through the TOSA backend, and we had a really active conversation going on behind the scenes on Discord involving Anish, Vivek in particular, whom I would like to call out, together with Eric and me, to work out some of the remaining details for boot, which was already almost close to the point of working when I had switched companies recently. I moved from ARM to Cruise. So I was able to successfully help Vivek, together with Eric also contributing a couple of legalizations, and we're at the point where everything is working properly for boot, and we're actively working on the few remaining issues for GPT-2, for which there are approximately half a dozen remaining legalizations, most of them quite trivial and should be easy to address. And the work on this has begun. So that's really the status update on TOSA, and it's been great recent progress, particularly in the last 2 or 3 weeks. So thank you very much, Vivek, once again.
Yeah.
Thanks.
Yeah, thank you everyone for the work on this. It's exciting to see this stuff coming up online. All right, Tanyo, do you want to talk about the MHLO updates? I think you're muted. Oh, good.
Yes. Hello, everyone. Over the past 2 months, we have accomplished the end-to-end compilation pipeline based on Torch-MLIR MHLO and MHLO to Linux. Moreover, we added new configurable options, backend verification, and end-to-end unit tests to Torch-MLIR MHLO. The pipeline passed over 250 end-to-end unit tests, which is more than the one based on TOSA. About 70 operator conversion patterns have been added to Torch-MLIR MHLO, which can be categorized into basic, linear, reduction, pooling, gather, and view-lex. These conversions are fully dynamically supported. With the ResNet 18 and TinyBird examples have been merged into the main branch. I am proud to say that we had completed the promise we made in the initial RFC. Thanks to the contributors from Alibaba Blade Disk dev team and ByteDance AML. Sean, next slide. Next slide, Sean.
Oh, is this the
Okay.
one? Oh, yeah, here we go.
Yes, this one, yes. The adoption progress in Blade Disk of Torch-MLIR shows that Torch-MLIR can be used to support compilation of different PyTorch models with fallbacks. We ran a small set of Torch-bench inference compilation workloads on NVIDIA A10 GPU based on Blade Disk plus Torch-MLIR two different PyTorch capture methods are used in the examples. They are Torch Dynamo and Torch Script. The entry and latency speed outs, the number of compiled clusters, total compiled nodes are recorded per model basis. The average statistics across models shows that Torch-2 MHLO operator coverage are sufficient to get performance gains. Thanks, John. Please take over.
Thank you, Tenyo. This is really exciting. I mean, this is like, like all these industry standard models. It's great to see them working and with full dynamic shape support. I have to really thank you for paying attention to full dynamic shape support on the MHLO backend. Anush?
Quick question, Tanya. Thank you. This is awesome work. I just wanted to get your thoughts on like what other models you're thinking of adding support for, like BERT, GPT. Are there any other models that you're thinking of other than the Torchbench ones? Because we have some customers that are interested in the MHLO roadmap and would like to get some color on what you're thinking as the next ones.
In recent schedule, we will support models in Torch benchmark firstly, and later we will also try to support GPT-2 and other models you have said.
Okay.
Yeah.
Cool. Thank you.
Great. Anush, Sambhav, or Ashay, do you want to talk about the CI and build stuff? There's a lot that's happened here.
Sambhav, you want to go for the Dockerized part? And then Ashay can do the pinning in Windows.
Sure, yeah, sounds good. I believe a lot of this initially started off with having the ability to reproduce CI locally and any CI failures locally. And so having a Docker setup to have a local reproducer exactly like you would run in GitHub Actions is critical to that. And Anush and Ashay and others have been really helpful here to kind of spearhead this effort. We now have both CMake and Bazel builds Dockerized, and so you can run them locally, and the same holds true for the GitHub Action workflows. And Anush has actually taken it to the next level where we've also integrated the CI with the release script. So the same scripts are being used both for CI as well as release builds. And it's super configured. I just saw Raghavan join, so I think Raghavan has a lot of good feedback as well. He has tested this out internally, and he saw tremendous benefits to not having to go through the non-Docker setup for CMake. So yeah, really thankful that we were able to get this in.
Thank you, Shambhav. Thank you for all the work with that. And Ashay, you want to cover the pinning and Windows build?
Sure, yeah. In fact, I'm building on top of the work that Sambhav and Anush did on Dockerizing the CI. So previously we had, or of late in the last, I guess, a couple of months, we've had a few build breakages because of API breaking changes in PyTorch nightly. Led by Anush, the main idea behind this work was to pin the PyTorch nightly, excuse me, PyTorch version to one that works with Torch-MLIR, but B, also to auto-update it on a regular or a periodic basis. And so we have the changes in a separate GitHub Action script. We're still fine-tuning the process. So going forward, there will still be a few changes, but at least you should not see any build breakages. If you do see them because of PyTorch versions, do reach out to me. The secondary benefit of this work is that hopefully, or at least we predict that in the coming weeks, the builds should be a lot faster as well because they'll hit the cache. And hopefully that will increase our developer velocity. So that's about the pinning. We also recently had enough progress to be able to build Torch-MLIR and run all the end-to-end tests on Windows. This is, of course, a shared effort. This is started by some folks, I guess, external contributors to Torch-MLIR, by Anush and other from me and Stella from Microsoft as well. So yeah, if you run into any of those issues, do let us know. But that's all from my side.
Thanks, Ashay. Thank you. That was it's really nice to see the Torch-MLIR build. I think yesterday I got all the Python tests and everything running with my PowerShell, and now that's going to be my primary development platform to make sure we flush out all the Windows issues. And I think we'll also get Erie to do the same thing so that we get first class Windows support. We have good Mac OS and Linux support, but we want to be inclusive for all the deployment cases, and Windows is a big part of that. Thank you. And I think this one there was some GitHub changes that went on. They changed, but I think Daniel from Sean's team added this. So now we have a website and GitHub pages that's updated with the latest build, and it'll show the pinned version of Torch-MLIR and the pinned version of Torch. So when we install, we just have to give that location with the -f, and you'll get both Torch-MLIR and the Torch version that's corresponding to that. Cool. Any questions? We can go to the next slide. I think Sambhav, you want to talk about the Bazel test?
Sure. Yeah. So what this includes is improving the Bazel support for running both unit and integration tests. So at this point, our upstream Bazel setup only includes the builds, and we have a Bazel setup to run the tests downstream, but it's closely tied to the Cruise Bazel setup. So I'm working on kind of decoupling that and making it more native to Bazel, and then upstreaming that to Torch-MLIR so we can improve our CI for the Bazel build. That's the first item.
Cool. And then I think we're just going to try to lock in the Windows CI. Kind of put. I'll talk to Ashay and we'll see what's the best way to set it up. But we'll set up a Windows CI and also a nightly release to build wheel packages for Torch-MLIR along with the Mac OS and the Linux builds that we do now. And then we're going to try to start pushing the Torch-MLIR releases to PyPy, so you don't have to give the -f also. I think we are at that point. We just need to enable audit wheel, and then it should be able to be done with just a few lines of code. And then there's a much more longer term item where I think came out of the work Quinn was doing to see if we can make Torch-MLIR like an embedded project without any external dependencies. So projects like OnyxMLIR or others can take a dependency, but that's a little further out. I think that's all we had. Suraj?
So this question is probably for Anush or Sean. Have you ever considered having the heavy depth test as part of the CR or build?
Yeah, so we initially introduced the heavy depth tests to be able to test some of these larger, heavier dependency tests. What we quickly found, though, was that some of the more difficult models required a bit more work than we could do, and they required a bit more infrastructure than we could do inside of that relatively simple setup. So actually, right now, Anush and his team are hosting the inside of Shark, something called the Shark Tank, which Anush is great at the marketing names. We need help. And there they have the instructions, or the instructions and scripts. Actually, it's all automated. How to generate some of these larger model tests. So we had not, basically the short answer is we had not anticipated how much sort of wrangling some of these models needed to get them into the form that we could accept. Like an example of this, for example, would be that, for example, if you want to do like a training workload right now with Torch-MLIR with the regular AOT flow, you need to use AOT AutoGrad to calculate the gradients. And so that makes things, that requires a bit more infrastructure than we were kind of willing to put together in the heavy depth tests. So the short answer, or the second short answer is I'm almost starting to think that we should deprecate the heavy depth tests. Yeah, is that helpful?
Okay, thanks. That's a sort of complexity for me. I had trouble building it on M1 too, and recently while working with Vivek, we did work with the content in the Shark Tank, I think. So probably we need some clarity here, even if it means just deprecating those tests.
Okay, yeah, great. Let me take an action item for that.
Yeah, and just to add to what Sean said, so in the Shark Tank, we run all nightlies. We get the latest Torch-MLIR binaries, and then we run that through, I think it's coming up on like hundreds of models with different variations, static, dynamic, etc. So it gets a full set of tests. The moment something breaks in Torch-MLIR, we know right away. Like when Ashay and I was working over the weekend, there was something with the pinning that went wrong. Immediately that broke, and then we worked to fix it. We'll make it easy enough to say, hey, this is how you can run full suite of tests with Torch-MLIR, and give you some documentation so it's an easy entry point, and how to develop with all those models also, so that you can still have Torch-MLIR, but you can get all the lowerings of all those models, and you can still target whatever you want, right? You'll just get all the lowerings for free from that perspective.
Yeah, a little bit more context here. Yeah, one of the things we've discovered in this process is that, as I said, there's a significant amount of wrangling that has to be done to get these models into a form that we can accept in terms of, calculating gradients or, gosh, I don't know, just so many different things, honestly. So right now, so Torch-MLIR, we obviously want to make it super usable and have everybody be able to just throw a random Torch model at it. But in the current state, because we're going through Torch script and or Torch JIT trace or whatnot, there's a significant amount of brittleness in that flow, which is what we're working long-term to fix with the Torch Dynamo-based flow. So that should make this entire process like totally robust in 1 to 2 years, but it requires a lot of working with upstream PyTorch on this new technology.
Sean, just me. And while that's happening, meanwhile, like we plan to kind of like reduce the impact of all the nuances of each model requiring this, and some of the model requiring something else, and we want to make sure everything gets into Torch-MLIR, but we also want a push button like, hey, give me all the models, give me stable diffusion, give me Bloom, right? It should just work, which is what we started with heavy depths, but we needed like little more scaffolding around it, which is what we want to do with Shark Tank. And so you'll have that, and we'll add instructions on how a Torch-MLIR dev can just leverage those and still have your like pip install -e and use your Torch-MLIR environment and get all the lowerings of all those models through, which will also give velocity for like MHLO lowerings, TOSA lowerings, whatever else we want. The front end is already like made robust for you to just turnkey use.
Yeah, Stella asks, is Shark Tank almost becoming a first-class asset in and of itself, kind of like how the backend contract is becoming a good consolidation point for front-end conversions?
I think so. And we're happy to organize it in a clean way and keep it in a way that can be used without any further dependencies downstream. So essentially, what we want to enable it to become as like you can get all those models, and then you lower down into Torch-MLIR and compile, and you can flip the flag and get whatever else you need, and not have to worry about going through it individually. Yeah, so open to feedback on how to make that an asset that can be used across just what it's used for in Shark.
Yeah, Anush, let's follow up about that, and let's figure out some way to make this a bit more, make the projects a bit more, make the relationship a bit more obvious. So I think this arrangement has worked extremely well for where we are right now because of the limitations of Torch script and Torch trace. This separation between sort of all the kind of, I hesitate to call it this, but kind of like unclean code that has to be done to put it into the right form to be scripted or traced, compared to, so that code currently lives in the Shark tank. All that, it's a significant amount of work and figuring out exactly how things are going to work. And then keeping the Torch-MLIR project itself, like the Torch-MLIR repo, kind of lean, mean, and like very technically clean. And so that separation has worked really well for us. And yeah, I think that, but making that relationship more obvious will be great. So looking forward to that. Cool. Let's see. I think this is the last topic. This is just an FYI. So there's this project which is actually larger than Torch-MLIR in scope and use cases. It's called TCP, or Tensor Compute Primitives, and it's sort of like MHLO, if I can say it that way. It's kind of at a similar level of abstraction, and so this is an MLIR community effort, and due to logistic and administrative reasons, we're actually going to it's going to be incubated on a branch of Torch-MLIR. So as a general Torch-MLIR developer, you can actually ignore those PRs. But while this is happening, and the belief is that as this starts to show value, it should become its own standalone item. TCP is not specific to Torch in any way. TCP is not specific to like any particular front end or lowering path. It's designed to be its own thing. So, but selfishly for ourselves, in this diagram, I show a little bit about how we can potentially greatly simplify our backend lowerings. So in our current system, we have basically MHLO, TOSA, and Linog. And right now they're three totally independent lowerings. In the future, we're hoping to basically have most of the lowerings go through MHLO or stable HLO. And then that should cover a large percentage of the ops. And then we'll use some of these transitive lowerings that are being developed or exist to do the rest of the conversion. And then for the ops that can't be covered by MHLO, drilling down directly into TCP, and if absolutely necessary, going directly to Linog. I don't have a branch going directly to TOSA because TOSA is kind of a subset of TCP and MHLO. So that should be, we should not need that that branch. But this should give us a much greater op coverage consistency between all the backends. But this is a longer term project, so I don't expect this to pan out maybe for another year or more. But yeah, just an FYI, you can ignore this, or whenever you see TCP, that's what it is.
Thank you for the summary, Sean. Just to give a few pieces of additional information. These PRs are going to be reviewed. They're going to be full scope, even though they are part of a branch. We treat them as if we are contributing to the mainline MLIR or to the mainline Torch-MLIR repositories. So there's going to be a formal RFC process with the inclusion of the wider MLIR community into each one of these PRs. And to date, we only have the boilerplate MKDR PR, which has already landed, establishing its position and the basis of TCPs to be able to consume Torch content in a much more effective manner. And therefore, anybody from the community, the Torch-MLIR community, is welcome to join and was part of the PRs too, of course, even though typically you want to ignore them at the beginning. But if it sounds remotely interesting, please feel free to comment.
Yeah, thank you, Suraj, for setting up that process and the due diligence there. I'm really excited to see where this goes.
Do you guys need a CI?
That's a good question. Sanjay?
How do you make sure the commits don't break, right? So you have to at least build something with TCP. Right?
Yes.
Maybe it would.
We probably do.
Yeah, I mean, this project is like literally starting like on the order of like weeks ago. And so just speaking from the history of Torch-MLIR, you know, back in the dawn of Torch-MLIR, it definitely took us more than a few weeks or months to get to the point where we needed CI. But if this grows much faster, then yeah, perhaps we can need it. And we're happy to also host that as well. But we need to, we'll have to adjust the notifications to avoid spamming people.
All right.
Great. And I think that is the last slide. Does anybody have anything they want to discuss, Q&A, or anybody who wants to introduce themselves to the community? All right. Well, we have about 10 minutes left if anybody wants to bring anything up.
Hi, Sean.
Mhm.
I have some questions regarding that ML program stuff that we are doing for the large models.
Mhm.
So, the first question is that I ran the ResNet and Bloom via like that ML program thing, like by cherry picking your patch, and I didn't think that the weights are getting stored anywhere because I didn't find a file. Second thing, the
Vivek, 1 second. So we actually have a large audience here, and they may not all be interested in this specific topic. So why don't we find another place to talk about this, just so that we keep this meeting on topic. I'd be glad to help you.
Yeah, sure, we can do that.
Okay, great. Any other general Q&As, project level stuff? All right. Well, it looks like we're going to get 8 minutes back. Thanks everybody for joining. And I look forward to seeing you next month. And I will talk to you then. Thanks everyone. Bye.